Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.4, Lobel rule and limits of indeterminate form. Number one, Lobel rule or LH rule. Suppose fx and gx are differential and g prime x is different from 0 on an open interval I that contains A and limit x approach A fx over gx is either 0 over 0 or infinity over infinity. That is, it has an indeterminate quotient form. Then limit x approach A fx over gx is the same as limit x approach A of f prime x over g prime x. To apply LH rule, rewrite the function of any indeterminate form into a rational function. A little history on Lobel. Lobel is a French mathematician. He published this rule in his 1692 book, Analysis of the Infinitely Small for the Understanding of Curved Lines. It is the very first differential calculus textbook. However, most people believe that the rule was discovered by the Swiss mathematician Johann Bernoulli because Lobel usually exchanged ideas with Bernoulli, and Bernoulli is much more famous. Let's move on to number 2, limits of indeterminate form. Example, find the following limit. First one, limit x approach 0 on the right side, ln1 minus x over x. And do a direct sub here, and we say that we have a ln1 over 0, which is 0 over 0. So ta-da, it's indeterminate quotient. LH, limit x go to 0 on the right side, derivative of ln1 minus x over derivative of x, limit x go to 0 on the right side, 1 over 1 minus x multiplied to the derivative of 1 minus x, which is negative 1 over 1. And then from here, we can do a direct sub. We'll have negative 1 over 1 minus 0, which gives us negative 1 as the limit. B, limit x go to 0, e to the 4x minus 1 minus 4x over x squared. Direct sub, we'll have a e to the 0, which is 1 minus 0 over 0 squared, 0 over 0. So use LH rule. And limit x go to 0. Derivative of the top is e to the 4x times 4 minus 4 over derivative of the bottom is 2x. And after the direct sub, we'll see that we have e to the 0 times 4 minus 4 over 2 times 0. So it's 4 minus 4 is 0 over 0. another indeterminate quotient. So reapply LH. Limit x go to 0. Derivative of the top now is e to the 4x times 4 times 4 over 2. And then from here we say that there is just a limit of x go to 0. A e to the 4x. So what are direct sub? We have 8e to the power 0, which is 8, and that is it. It is the limit. Pretty cool. Okay, here comes C. Limit x go to 0, sine 3x times sine 5x over x squared. Well, if we do a direct sub, we say that we get a sine 0 times sine 0 over 0 squared, which is 0 over 0. And it can be a little clunky, taking the derivative of the top and the derivative of the bottom. There's a much better way to deal with this form, and that is, well, we can use the limit x go to 0 of sine x over x equal 1. Now here come a proof of it. Limit x go to 0, sine x over x. Do direct sub, we get 0 over 0. So use LH rule. And limit x go to 0, derivative of sine x, cosine x, derivative of x 1. And now with the direct sub, cosine 0, which is 1. Ta-da! That proves it. So let's use it. Limit x go to 0, sine 3x times sine of 5x over x squared. Well, we want the angle in the denominator to be the same. So I'm going to multiply by 1 over 3x times 5x over 1 over 3x times 5x. Let's just multiply by the number 1. Limit x go to 0. And then from here we have a sine 3x over 3x times sine 5x over 5x. And then this one is over x squared over 15x squared. So I have limit x go to 0 up 1 over 15. Oh, actually, you're gonna split out the limit using the limit law. Limit x go to 0, sine 3x over 3x multiply to limit x go to 0, sine 5x over 5x. And then everything is over limit x go to 0 up 1 over 15. Apply the fact that limit x go to 0 of sine x over x is 1. We have 1 times 1 over 1 over 15. So the limit is 15. Yay! Super nice. Let's move on to do a few more. D. Limit x go to infinity. X sine of pi over x. Let's do a direct sub here. We get an infinity multiply to sine of pi over infinity. So infinity times psi of 0, which is 0. Indeterminate product. We got to turn it into a quotient. We can always turn a product into a quotient using this little trick. Limit x go to infinity. X is the same as 1 over x times psi of pi over x. So now we have limit x go to infinity. Psi of pi over x over 1 over x. Yay! Let's do a direct sub here. See what we have. Psi of 0 over 1 over infinity. So that's 0 over 0. Yay! Indeterminate quotient. Use L'Hopital rule. And ta-da! Limit x go to infinity. Derivative of psi is cosine pi over x. And we're gonna multiply by the derivative of the inner function, which is derivative of pi over x, or just pi derivative with respect to x of 1 over x. I'm not gonna work it out because the derivative of the bottom is the derivative of 1 over x. And notice that they cancel each other out. Haha. Very cool, huh? Limit x go to infinity. Pi cosine of pi over x. And now we can do a direct sub here to get pi cosine of 0, which is pi times 1, and that is pi. Slick. Okay. Let's take a look at E. Limit x go to 0 on the right side. 1 over x minus cosecant x. Let's do a direct sub here. 1 over 0 on the right side minus 1 over psi, because cosecant is 1 over psi, 0 on the right side. Well, 1 divided by a number getting smaller and smaller tell us that the quotient is getting bigger and bigger. So what we have is infinity minus infinity. We need a quotient in order to use the L'Hopital rule. So rewrite this as limit x approach 0 on the right side. 1 over x minus 1 over psi x. And then use the common denominator. LCD. Limit x go to 0 on the right side. Psi x minus x over x. Psi x. Now do direct sub. Ta-da! Direct sub. Psi of 0 is 0. So 0 minus 0 over 0 times 0, which is 0 over 0. And then we can use LH rule. That gives us limit x go to 0 on the right side. The derivative of psi is cosine x minus 1. The derivative of the bottom is we have to use the product rule. X times cosine x plus sine x times 1. And now let's do a direct sub. See what we have. Direct sub. Cosine of 0 is 1, so 1 minus 1 over 0 times cosine of x is, when x go to 0 is 1, plus sine of 0 is 0. Oh, we still have 0 over 0. Well, it is an indeterminate quotient, so we just have to reuse or reapply L'Hopital rule. Limit x go to 0 on the right side. The derivative of cosine negative sine x over, well, for rule, x times negative sine x plus cosine x times 1 minus the derivative of sine is cosine. Oh, that's plus cosine x. Yeah, this look good though, because if you look at the denominator, when we do the sub, it is no longer 0. And when the denominator is no longer 0, that is it. We are getting the limit. So now do a direct sub to get negative sine of 0 over 0 plus cosine of 0 plus another cosine of 0, which give us 0 over 2, and that is 0. Ta-da! I like this problem. We got to do more advanced example. Let's go. F. Yeah, let's do a direct sub here. See what we have. 1 minus 2 times 0 on the right side. 1 over 0 on the right side. Well, 2 times 0 is just going to be 0. I have 1 divided by 0 on the right side is infinity. So 1 over 1 to the power infinity. Ta-da! Indeterminate power. Well, we need to somehow move the power in front or get rid of the power. And the only way to do that is we get to take ln on both sides. So we're going to let limit x go to 0 on the right side, 1 minus 2x, 1 over x equal L. Next step is take ln on both sides. And we can move the limit in and out because of a limit law. So we can move the limit outside. Limit x go to 0. ln 1 minus 2x, 1 over x. Okay, on the right side, just ln L. Take care of that one later. Now we have limit x go to 0 on the right side of 1 over x, ln 1 minus 2x. And let's write this as a quotient. ln 1 minus 2x over x. Let's do a direct sub here. We have ln 1 over 0 on the right side. Well, which is 0 over 0. An indeterminate quotient. So apply LH rule. Limit x go to 0 on the right side. Derivative of the top 1 over 1 minus 2x. Multiply to negative 2. And down here we have derivative of x is 1. We'll simplify this to have limit x go to 0 on the right side, minus 2 over 1 minus 2x. And now we can do a direct sub. Minus 2 over 1 minus 0, which is negative 2. However, what have we done here is we found the limit on the left side of the equation. Now we know that this limit here is exactly L and L. Because what we did was that we did this part. So to solve for L, take E at the base. And E to the negative 2 is L. Or 1 over E squared.